the potential difference across all components that are in parallel will be the same. Here are some examples of circuits with parallel components, which remember are when the components are on branches alongside each other. So there's no path around the circuit that passes through both, like with these two lamps. But how does this affect their potential differences? Well, let's suppose this bottom lamp has a potential difference of V1, and the middle one has a potential difference of V2. Then, because the lamps are parallel and they are the only components on these branches, these potential differences must be the same. In other words, V1 equals V2. You don't need to understand why this happens with parallel components, but it's a very important rule you need to make use of in problems. For example, this explains why we always connect voltmeters in parallel. But be careful you don't use this in the wrong situation. For example, in this circuit on the right, we can also say these parallel lamps have potential differences of V1 and V2, which will be the same. But what about this third lamp, which we could say has a potential difference of V3? If we have parallel branches in the circuit, does that mean that this is also equal to V1 and V2? No, because this lamp is not in parallel with the other two. Its branch doesn't run alongside these, and we can form a path that passes through this and one of the other lamps. That means the third lamp must have a different potential difference to the two parallel ones. In other words, V3 does not equal V1 or V2. Now, you likely won't be given a complex situation like this in a GCSE exam, but it's important to be aware of so you have a good understanding of when we do use this rule. But what rule do we use for currents in parallel? The current will be split between the parallel branches at a junction. Remember, this is because charge carriers will travel down different branches of the circuit. And then, the total current is the sum of currents on parallel branches. Let's look at another parallel circuit and understand what's happening to the current. Let's say the current travelling on the middle branch is I1, and on the bottom branch is I2. Then these currents will join together when the branches meet, forming a new current that we'll call I total. Then we can say that I total is equal to I1 plus I2, which is another important rule for parallel circuits. Here, because the charge carriers are meeting up at the junction, the current they carry will be found by adding together the currents when separated. Also remember that on a branch of a circuit, the current is the same everywhere. So we'll have this same total current here. We can then imagine this current splitting up into I1 and I2 after the junction. Now let's try applying these two rules to an example problem. A circuit consists of a lamp connected in parallel to a resistor. The potential difference across the lamp is 8 volts, and the current through it is 5 amps, while the current through the resistor is 2 amps. We've also been given a diagram showing this circuit. Find the potential difference across the resistor and total current in the circuit. So we need to give 2 answers to this problem. Since this is a simple parallel circuit, we'll be using the rules we've just learnt. Let's start with the potential difference. So in step 1, determine the relation between the potential differences of the lamp and the resistor. Remember that since these components are in parallel, we can use the rule V1 equals V2. In other words, the two components have the same potential difference across them. So the potential difference of the resistor is also 8 volts. In step 2, add the currents to find the total, where the total current we need to find would be the current flowing here, before or after where the branches join together. So we do this using the rule I total equals I1 plus I2, since we add together currents in parallel to find their total. So in this case, we do 2 amps plus 5 amps, using the currents from the resistor and the lamp, which gives us a total of 7 amps.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!